Back on this greatest common divisor video series, and you may have noticed something kind of strange with the code, and that is that I have these brackets around my code here, and there's a reason for my madness here. When I put brackets around code, they call that a block. That's a block of code. And blocks of code can have their own internal variables, and those variables can only be used within that block of code. Now let's take, for instance, if I didn't put brackets around this, okay? Let me take rid of this, and I'll get rid of this. And you have errors everywhere. Right here, we got errors. Well, not here so much, but say I get rid of this. I get rid of this bracket and this bracket. Okay, now we're going to get errors a bunch of places. Okay, what they're saying here is that we have a duplicate value. Okay, because if you don't put a set of brackets around here, this variable minimum has already been defined within the body of the body of the main method. Okay, that variable is defined in the body of the main method. So what it's saying here is you've already defined min, you've already defined k, you've already defined GCD. What are you doing to me? Okay, well, you can fix up those errors by simply putting a brace around the code that logically belongs to itself. Okay, and I'm going to do the same thing over here. And I've now defined a block of code. That block of code has its own variables, and even Eclipse tells you this. Like, take a look at K. If I hover over K, over that, it says K is defined here, and this is the references. They're highlighted here, but this K is not the same. This K and this K are not the same. This K is a variable defined to be used within this block from where it has been defined to the end. And once you're done with the block, those variables are gone. They died. They went into variable heaven. Now, when you establish another block, you can define your variables. You can name them the same. And even Eclipse is telling you that K is not the same thing as this K. So understand the scoping rules, and you'll be, every language has a scoping rule, and this is just one of them. Scope is where a variable is defined. Okay, so that's a neat little feature you might want to use. And you're going to use them a lot in methods, because methods have blocks. Okay, methods have blocks because this is a method, main method. This is a block, and inside that block you have your own variables, the local variables. Now, but what I'm just basically saying is that you can define blocks within blocks within blocks. And each block can define its own values. Its own variables. So I think we left up with version 4. Okay, so what do we do with the version 4? Well, this was old school, using the Boolean variable. Did we find what we're looking for? You really don't need it. We can still basically find the minimum. K is my factor that we start off with the minimum value as a factor. We can do the same thing with a while loop by simply in the condition. Listen, while look, this is different from this statement here. What this is basically saying, while K does not divide evenly into both numbers. That's what that highlighted condition says. While K does not divide evenly into both numbers. Either K does not divide evenly into N1, or it doesn't divide evenly into N2. Notice they're not equals. So it's a different way of looking at it. Then decrement K. Try the next iteration, let K go down 1. If it still doesn't divide equally into those numbers, decrement K. So basically with the 36 and 24, the minimum is 24. And remember what this is? This is the conditional operator here. Okay, if N1 is less than N2, then the result of this expression is N1, which is, okay, 24. Okay, if this is false, N1 is greater than N2, then N2 is the smallest value. That's considered the minimum. It basically takes the place of an if statement here. So that's a smaller loop, gets to the point a lot faster. I believe version 5 is essentially the same as version 4, only I converted a while loop into a for loop. I have my condition here. Condition is k equals min. Okay, we've initialized it once. If you can say that k does not divide evenly into n1, n2, then do the body of the loop. Well, there is no body. There is a semicolon there, right there. There's no statements there. That's okay, perfectly okay for the loop to be, for the body of the loop, or the for loop to do nothing. But then what we do is we decrement. After we do nothing, we decrement k to try, see, from 24 to 23, 22, all the way up to 12 in our example of 36 and 24. Eventually, you're going to hit 12. 12 divides evenly. 12 divides into 24. That's equal to 0. That's false. And 36 divides by 12 does not equal 0. That's false. An OR is false when both the arguments are false. We exit out. 68 is now GCD is equal to 12. We print out the value. We're good to go. We're done. And then the last version of this program is going to be basically a break statement. And this is probably the cleanest way I would do this. If you're bothered by this this OR statement here, then basically what you're going to say is this. Listen, take a for loop. Start at the minimum. As long as k is what you're dividing by is bigger than 0, decrement it. Okay, so we're starting from 24, 23, 22, all the way down to 1, not including 0. If you find that k divides, if k divides evenly into both numbers, that's why we have an and is true if both are true. 12 divides into 36 evenly, and 12 divides into 24 evenly, then in this case, k divides evenly into those numbers, just break out of the loop. You found what you're looking for, you're done. K has the value of the GCD at that point once we break out of the for loop. And we can go ahead and print this out. Okay, we studied, I think we beat the GCD to death. I think we'll stop here and we'll go on to other examples of looping in the next video. Okay, bye.